Hi, welcome back. In this video, we're going to look at special right triangles. The second kind are 30, 60, 90. We've already talked about our 45, 45, 90, where we said the 45, 45, 90 triangle comes from a square dividing with a diagonal. And we said if we know one leg, we know the other leg, and then the hypotenuse is that leg times the square root of 2. Okay, so if you need extra help on that, make sure you ask during tutoring or during sync time, or go back and rewatch those videos. But today we're going to focus on our 30, 60, 90 triangle, which comes from dividing an equilateral, equiangular triangle with an altitude. Remember, if it's equilateral, all of these sides are exactly the same. Okay, if it's equiangular, all of these angles are exactly the same. So you can see they're all 60, so they add up to their 180. When we draw an altitude in an equilateral triangle, it's going to divide this angle equally. So I'm going to end up with 30 degrees here and 30 degrees here. It's also going to divide this opposite side equally. So this piece here will be exactly the same as this piece here. Okay, so what we can see is we end up with two triangles that are identical, with single tick mark, a double tick mark, and a reflexive side, a single tick mark, a double tick mark, and a reflexive side. So by side, 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 the left side and the right side are exactly congruent. Okay, so that is where we end up with our 30, 60, 90. We have our 90 degrees that came from our altitude, our 60 degrees that came from the corner of the whole equilateral triangle, and then our 30 degrees that came from dividing it into two pieces. So when we do this, we're going to see we end up with, of course, a hypotenuse across from the 90-degree angle. And then we're going to have two legs, and they're not going to be exactly the same like they were in a 45, 45, 90. Remember, anything across from a smaller angle is going to be smaller or shorter. Anything across from a bigger angle is going to be bigger or longer. So you're going to notice we're going to end up in every single triangle with what we call a short leg, a long leg, and then our hypotenuse for our 30, 60, 90 triangle. It's very important to identify which of these three sides is short, which is long, and which is the hypotenuse. Okay? We always will start with the short leg, whether that's what we're given first or not. That's always going to be kind of our go-to, what we're going to look at first. So we always want to make sure we either are given the short leg, or if we're not given it, we find this first before we find the other two. Okay? So if I go back to my equilateral triangle, where that short leg is, if I call that x, that means it's also going to be x over here on this other side. So this whole side then of the equiangular or the equilateral triangle is going to be x plus another x. So 1x plus 1x means this whole side is 2x. So each of my sides of my triangle, of the original triangle, are all 2x. When I come back over here where I've divided it in half, that side is now my hypotenuse. So I know my hypotenuse is going to be 2 times whatever this short leg is. So if the short leg is 5, this is 10. If this is 7, this is 14. If this is 12, this is 24. You could also work backwards. If this was 30, this must be 15 because I work backwards. The long leg is a little bit more challenging to find, okay? Because if we were going to put this in the Pythagorean theorem, we would do the leg squared plus the leg squared equals the hypotenuse squared, right? So we would do this long leg squared. I'm going to get a different color so it doesn't all blend together. Okay, so I would get the long leg squared, which I don't know what it is, plus my short leg squared, I'm going to call that x, is going to equal c squared, my hypotenuse squared, which I'm going to put in parentheses so I remember to square both the 2 and the x. So this is really my long leg squared plus my x squared equals 2 squared and x squared, so that's really 4x squared, because I kind of just distributed that square in there. Okay? All right, so now if I'm trying to figure out what the long is, I have to get rid of this x squared. So I'm going to subtract it. Minus x squared minus x squared. Okay, so that's going to give me my long leg squared is going to equal, because these are going to cancel to 0, 4x squared minus 1x squared is 3x squared. to get rid of this square, I'm going to square root. And if I square root one side, I have to square root the other side. So if I square root here, I have to also square root here. Okay? On this side, my square and my square root cancel, leaving me with just the long leg. Equals the square root of 3x squared. Now to simplify that, you can't just square root part of it because you can't square root that 3 without getting an ugly decimal. So I'm going to rewrite this as the square root of 3 times the square root of x squared, because that I can simplify part of it. I know that squares and square roots cancel, right? That's how I knew that this became just the long without the square or the square root on it. So this is really just the square root of 3 times x. So my long leg is the square root of 3 times just a plain old x. And when we write that, if we were to do like x times 2, let's say, we would write that as 2x because we like to put things in a nice pretty order. Whenever you have a variable multiplied by a square root, or anything really multiplied by a square root, we tend to write the square root second. So when we write this, we really write it as x times the square root of 3 instead of square root of 3 times x, just because that way it's easier to see that the x is not inside that square root of 3. So my long leg is my short leg times the square root of 3. So I'm going to come back over here and add that to my picture. My long leg is the x times the square root of 3. Okay, so my short leg is x. That's the one we always want to find first. Find this one first. Try to make it a star. Find the short leg first. If you're not given it, find it. And then you can go from there and double it to get your hypotenuse, and you can multiply it by a square root of 3 to get your long leg. This is on your formula chart. Okay, so when you're doing your test, you do have access to this formula chart on your test, and you will see your 45, 45, 90. Okay, so now that we've seen where it comes from and we've seen what the formula looks like, when we come back in the next video, we're going to do some examples where we're going to apply my short leg as x, my long leg as 2x, my long leg as x square root of 3, and my hypotenuse as 2x. All right, so make sure you come back for the next video so that we can look at those examples. Thanks for watching.